Okay, so we are getting near the end of Unit 1. And what remains is for us to talk about the tools of science. And that means measurements, units, and something that is new to students entering chemistry, which is precision, accuracy, and how we have to treat the concept of precision in our calculations. All right, so let's get right into it. So first off, what are units? Well, units are the necessary label that is attached to any measurement that we take in science, right? So some of these are already very familiar to us, right? Like if we're measuring something to determine its length, then the unit that we'll use is the meter, okay? If we're measuring something to determine its mass, then the unit that we will use is the gram. If we're measuring something to determine its temperature, then the unit that we will use is the Celsius degree. All right, so these are units. Now, what we use to modify the unit is something called a metric prefix, and you're familiar with these as well, right? Kilo, milli, centi, these are all prefixes that we've used for years, right? Some of them might be not familiar to you, right? So for example, in chemistry, when we talk about the size of atoms, we use the picometer. And pico is a prefix that tells us that we're working with something very, very small, okay? So let's take an example here. The length of this paper clip. If I'm measuring length, then I use meter, right? Now, if I measure it and I use meter, the length is 0.078 meters. Now that seems strange though, because wouldn't I use a ruler? And don't rulers have centimeters? Well, yeah, because the unit meter is relatively large, right? I mean, you can stretch your hands out and you get something about the size of a meter. So a paper clip seems like it should be modified, and we do. If we were to measure this paper clip, we wouldn't say meter, we would modify it with the prefix centi. And centi means 10 to the negative 2. So that's 2 decimal places that you have to take away if you remove the centi, right? So if I was to get rid of the little c and just make it an m, then I would have to go 2 decimal places to the left, right? That's what that negative 2 is referring to, okay? Well, let's go the other direction. Instead of measuring something small like a paperclip, what if I asked you how far is the distance from Utica to Rochester, right? Well, again, length is meter. That would be 200,020 meters. That seems like a really big number, right? So if we're measuring something large or the length of something large, then we're likely going to use the prefix kilo. So I would say that it's 220 kilometers. Now, if you look at kilo is 10 to the third. That means that if I got rid of the K, I would have to add 3 more zeros to the number, hence the 220,000, right? So these prefixes are all used basically to take and add zeros and to make the numbers a little bit more manageable, right? So don't confuse the unit and the prefix, okay? They work together, but they are different in what they're trying to represent, okay? Now, when we talk about measurements, we also have to talk about the idea of accuracy and precision. These two terms are often incorrectly used synonymously. They do not mean the same thing, okay? Accuracy refers to how correct a number is. So for example, let's say that I have these 4 balances and they each have a certified 50-gram weight placed on them. Accuracy means that they measure the weight correctly. In other words, this balance and this balance are accurate, and these two are not. Okay? Now, how is that different from precision? Well, precision is the exactness of a measurement. Another way you can think about it, at least in this class, this works almost all the time, is to think that precision is how many decimal places our measurement can reach, okay? So we already said that these two they're not even accurate, so forget those, right? If you look at this balance, do you notice that it goes to the tenths place, 50.0? Well, that means that its precision is to the tenth of a gram. This balance, however, goes to the hundredths place. That means that its precision is to the hundredth of a gram. It gives a more exact measurement. This balance would be superior and would be more expensive. Okay, so accuracy and precision, they're not the same thing, but they both are important to us when we take our measurements. Okay, now the last idea here, the idea of uncertainty. So here's the way this works. Anytime you take a measurement that uses a device that you have to read and make an interpretation of, right? So for example, this ruler. If I want to know the length of that blue line, I use my eyes and I match it up to the little graduation, the little lines on the ruler. But do you notice that that blue object, whatever that thing is I'm measuring, it doesn't fall exactly in the center of one of those black lines. There's uncertainty in that measurement. And so we have to deal with that uncertainty in a well thought out and agreed upon way. Here's the way we do it. What we say is that you will always measure one place past whatever the smallest graduated mark is. And you will either decide that that one place past is a 0 or a 5. In other words, you have to add an estimated 0 or 5. Now, if you go back to that line, right, and you look at it, well, it clearly crosses the 3 centimeter. This right here would be the 3.5 centimeter, which means I have to go 3.5 and then I have to estimate. Does it look like the line is closer to the 0.5, in which case I would say that's a 0? Does it look like the line is closer to the middle, in which case I would say it's a 0.55? Well, if I look at it, and again, this is an estimate, I would say that that blue line is pretty close to the middle between the 0.5 and the 0.6. So I'm going to estimate that last digit as a 0.5, or excuse me, as a 5. And so my measurement would be recorded 3.55 centimeters. All right. That's the way we deal with those uncertainty measurements.